A gimbal is a pivoted support that allows the rotation of an object about a single axis. A set of three gimbals, one mounted on the other with orthogonal pivot axes, may be used to allow an object mounted on the innermost gimbal to remain independent of the rotation of its support. For example, on a ship, the gyroscopes, shipboard compasses, stoves, and even drink holders typically use gimbals to keep them upright with respect to the horizon despite the ship's pitching and rolling. The gimbal suspension used for mounting compasses and the like is sometimes called a Cardan suspension after Italian mathematician and physicist Gerolamo Cardano, who described it in detail. However, Cardano did not invent the gimbal, nor did he claim to. The device has been known since antiquity and may not have a single identifiable inventor. History. The gimbal was first described by the Greek inventor Philo of Byzantium. Philo described an 8-sided ink pot with an opening on each side, which can be turned so that while any face is on top, a pen can be dipped and inked, yet the ink never runs out through the holes of the other sides. This was done by the suspension of the ink well at the center, which was mounted on a series of concentric metal rings so that it remains stationary no matter which way the pot is turned. The authenticity of Philo's description of a Cardan suspension has been doubted by some authors on the ground that the part of Philo's Pneumatica which describes the use of the gimbal survived only in an Arabic translation of the early 9th century. Thus, the sinologist Joseph Needham suspected Arab interpolation as late as 1965. However, Cardan, author of the French translation which still provides the basis for modern scholars, regards the pneumatics as essentially genuine. The historian of technology George Sarton also asserts that it is safe to assume the Arabic version is a faithful copying of Philo's original, and credits Philon explicitly with the invention. So does his colleague Michael Lewis. In fact, research by the latter scholar demonstrates that the Arab copy contains sequences of Greek letters which fell out of use after the 1st century, thereby strengthening the case that it is a faithful copy of the Hellenistic original, a view recently also shared by the classicist Andrew Wilson. The ancient author Athenaeus Mechanicus, who flourished during the reign of Augustus, described the military use of a gimbal-like mechanism, calling it little ape when preparing to attack coastal towns from the seaside. Military engineers used to yoke merchant ships together to take the siege machines up to the walls. But to prevent the ship and machinery from rolling around the deck in heavy seas, Athenaeus advises that you must fix the Pythachion on the platform attached to the merchant ships in the middle, so that the machine stays upright in any angle. After antiquity, gimbals remained widely known in the Near East. In the Latin West, reference to the device appeared again in the 9th century recipe book called the Little Key of Painting Mappi Clavicula. The French inventor Villard de Hainaut depicts a set of gimbals in his famous sketchbook. In the early modern period, dry compasses were suspended in gimbals. In China, the Han Dynasty inventor Ding Huan created a gimbal incense burner around 180 CE. There is a hint in the writing of the earliest Sima Xiangru that the gimbal existed in China since the 2nd century BCE. There is mention during the Liang dynasty that gimbals were used for hinges of doors and windows, while an artisan once presented a portable warming stove to Empress Wu Zetian which employed gimbals. Extant specimens of Chinese gimbals used for incense burners date to the early Tang dynasty, and were part of the silversmithing tradition in China. Applications. Inertial navigation. In inertial navigation, as applied to ships and submarines, a minimum of 3 gimbals are needed to allow an inertial navigation system to remain fixed in inertial space, compensating for changes in the ship's yaw, pitch, and roll. In this application, the inertial measurement unit is equipped with 3 orthogonally mounted gyros to sense rotation about all axes in 3-dimensional space. The gyro outputs drive motors controlling the orientation of the 3 gimbals as required to maintain the orientation of the IMU. In turn, angular measurement devices called resolvers mounted on the 3 gimbals provide the 9 cosine values for the direction cosine matrix needed to orient the ship. Similar sensing platforms are used on aircraft. In inertial navigation systems, gimbal lock may occur when vehicle rotation causes 2 of the 3 gimbal rings to align with their pivot axis in a single plane. When this occurs, it is no longer possible to maintain the sensing platform's orientation. Rocket engines. In spacecraft propulsion, rocket engines are generally mounted on a pair of gimbals to allow a single engine to vector thrust about both the pitch and yaw axis. Or sometimes just one axis is provided per engine. To control roll, twin engines with differential pitch or yaw control signals are used to provide torque about the vehicle's roll axis. The word gimbal began as a noun. Most modern dictionaries continue to list it as such. Lacking a convenient term to describe the swinging movement of a rocket engine, engineers began also using the word gimbal as a verb. When a thrust chamber is swung by an attached actuator, the movement is referred to as gimbaled, or gimbling. Official rocket documentation reflects this usage. Photography and imaging. Gimbals are also used to mount everything from small camera lenses to large photographic telescopes. In portable photography equipment, single-axis gimbal heads are used in order to allow a balanced movement for camera and lenses. This proves useful in wildlife photography as well as in any other case where very long and heavy telephoto lenses are adopted. A gimbal head rotates a lens around its center of gravity, thus allowing for easy and smooth manipulation while tracking moving subjects. Very large gimbal mounts in the form 2 or 3-axis altitude mounts are used in satellite photography for tracking purposes. Gyrostabilized gimbals which house multiple sensors are also used for airborne surveillance applications including airborne law enforcement, pipe and power line inspection, mapping, and ISR. Sensors include thermal imaging, daylight, low-light cameras as well as laser rangefinder, and illuminators. See also, gimbal lock, Canfield joint, Hawley gimbal, universal joint, Cardan joint, Cardan shaft, gyroscope, keyhole problem, trunnion. References